All right, let's look at this question. Prove the identity. Left hand side we have 1 over 1 plus secant of a equals to 1 minus 2 cos a minus sin squared a all over cos squared a minus cos a minus 2. So to prove the identity, we're going to start using, in this case it looks like that the right hand side is more complicated than the left hand side. So we're going to deal with this side. First, let's rearrange what we have. Here on top, 1 minus 2 cos a minus sin squared a, we can rearrange that and make that 1 minus sin square a minus 2 cos a all over cos square a minus cos a minus 2. What we are doing is that we're trying to simplify the right hand side as much as we can, and we notice that there is a pattern. So here's the pattern that as soon as I started, I noticed that there is a pattern like that. So 1 minus sin squared a, that's a Pythagorean identity, so that's what I chose, and that's what you need to do. You need to look at patterns that show up in any of the statements so that you can actually manipulate it. So all right, let's go through 1 minus sin squared a. So here is the 1 minus sin squared a, that's a Pythagorean identity. That simply is cos squared a. All right, and the next is minus 2 cos a. All right, all over. Now in the bottom, cos squared a minus cos a minus 2, we can actually factor that. Cos a, and it's actually a straightforward factoring. It's just basically plus 1, it's actually minus 2 needs to be. All right, so now from the top we can easily factor cos a, the numerator, factor cos a out. We get cos a minus 2, and all of divide that by the denominator, which is cos a plus 1 in bracket, open a bracket, cos a minus 2. And now you can see the common factors. You can divide, and what you will have is cos a on top over cos a plus 1. Okay, and now you can look at it and simplify it more. All right, now that you look at the original, which is right here, this is the original to the left hand side, notice that the numerator right here is 1. That means we need this cos right here, this cos a, to be 1. So what should we do to make that 1? And whatever we do, we have to do it to the denominator, because we cannot change the value of this identity, or it is a rational expression, so that we can multiply, divide by 1, but that's basically what it can be. All right, so to do that, we're going to multiply the top by 1 over cos a, and that makes it 1 on top, but we can't just do that. We have to do the same thing to the denominator. We have to, because the entire thing here, that is actually 1. We're not doing anything. We're not changing the value of this fraction. All right, let's go through and solve, simplify. So that would be 1 right across, and here notice that the part that you're multiplying will be 1 plus 1 over cos a. That's the denominator. When you multiply the denominator, which is this, by that, you will get that. And that is 1 over 1 plus secant of a. And that's how you prove this identity.